One of those people will be. Huh? What? If you're tossing one. What? No, you're not. Sit over here and get this. Square thing is funny. What the? You're playing soccer? You're playing soccer? What the heck's that? What the heck's that? Wait, wait, tell us. Do they suck? I wasn't talking to them. Oh my god. Did they hurt? Hurts me like the first week. If you have rubber bands in your mouth the entire day, I feel like it would hurt. And you get used to it, doesn't it? You don't even feel it.
Alright, write down your homework, then pull out your books and notes. Get ready to go. Squire, get to work. Oh, hey, my bad, I dropped my pen. Oh, there you are. Alright, homework written down, then pull out your notes and your book. Talk about a couple things and then we will get into Unit 12.
Okay.
That would be something that would take at least every day.
People converse for it. For it. Oh.
40,000 Americans are injured by toilets.
Did you get that on Wikipedia?
Is that even true?
Get to work.
Or you can make it good. Did you make one? Make it. Yeah. I'm gonna do it tomorrow. Yeah, I'm in the process of. I have my sixth graders. But yeah, my sixth graders, I came up with one that helped me in Facebook and questions. So that was their homework. Short card. The back came with 3 flips. Everyone got 3 flips.
All right. A couple things as we get started today. Make sure that you have your notes up and ready to go, your book out. Tonight for homework, you're going to have to do 12.1 and 2. On 12.2, you need to make sure that you do the apply. Just number 7, though. Do not do all of the apply. Just do number 7. Just number 7. That make sense to everybody?
Yep.
Okay. All right. It's down to Mr. McCarter. Yes. You good?
It says I'm logged onto this, but it's saying, oops, there was a problem.
Oh yeah, it's doing that for me as well.
Strange.
Will it be on the textbook?
Oh, just download the textbook.
It's did that to me as well.
Just download it and it'll open up down here. Just download it, Cal.
I did.
All right. We are going to go through section 1 and 2 today. So I know we're up against a break next week. Here's what's going to happen this week. We are going to go through the first 6 sections of Unit 12. So we'll get through about 2/3 of Unit 12 before the break. I'll leave Socrative for you to review over the break, and then we'll finish it, the last 3 sections, and test when we come back. Fun stuff? Really good, exciting? Okay. Any questions about anything coming up this week? Or anything before we get going into the reading?
When are we going to start test grade?
Study hall. 240. 240.
You said that last time, and then I came and you said no.
Not last week. Was it the day you took the test? Come see me today, I'll show you the test today. Okay, so today we're going to talk about matter. Okay, we're going to talk about matter and why it matters. Madison, did you share your spiral with me? And Lily, I know you were absent. Just make sure you get the notes today. Okay. All right. Properties of matter. Let's open up to 12.1 and let's start reading with Callum.
Look around you. What do all the objects you see around you have in common? They're all made up of matter. Matter is anything that has mass and takes up space. Mass is the amount of matter an object contains. The amount of space an object takes up is its volume. Shall I continue?
No, next paragraph goes to Jared Brown.
Water is matter. A glass filled with water is heavier than an empty glass. A filled glass is heavier because water has mass. If you kept adding water to a filled glass, the water would overflow. It would overflow because the water takes up space.
Good. And the last paragraph down at the bottom, Julia.
My computer's hating me right now, so I'm trying to figure it out. It's working now. Just slow. Mine's keep
you read that last paragraph?
Air does matter too. A balloon filled with air is heavier than a balloon that is not blown up because air has mass. When you blow air into a balloon, the balloon gets larger and air takes up space.
Okay, so what did you guys have for notes? Who had what in terms of notes? Cal.
Anything that has mass and takes up space.
Beautiful. So matter is anything that has mass and takes up space. Good. Jared?
Water and air is matter.
Okay, so we could do example, water, and air. Squire?
Mass is the amount of matter an object contains.
Okay, so we can get real detail, go mass is the amount of what?
Matter.
Matter an object contains. Good. Anything else? Okay, so what is matter? So let's go through just some curiosities. Let's see. If we look starting back here behind Squire at this desk, is this desk matter?
Yeah.
Why?
Anything is.
Because it's taking up space.
Because it's taking up space. Does it have mass?
No.
Yes.
Yes. Yes, it
Yes.
does.
Yes.
All right. Think about it. One cohesive answer. Does it have mass?
Yes.
Yes. Good. Squire's calculator. Matter?
Yep.
Yes.
Yes. Squire. Matter?
No.
Yes.
Squire is matter.
So everything's matter.
Technically, everything is matter. If it has mass that we can measure, and it takes up space, okay, that makes it matter. Air takes up space. Think about air. Air is all around us. That's breath. Air is all around us. Okay? If I go like this, all I'm doing is just moving air out of the way. It worked. But you can still know that there's air all around you, right?
Mm-hmm.
Just moving it around. Okay? We'll get to that in the next section when we talk about different properties. Yeah.
Can sound waves be mass?
Sound waves don't have a mass. So sound,
But do they matter?
they move around, but they move around on the particles in the air. So they're a little bit different. Yes, Kinsey?
That's the one with the shares.
All right, let's read about properties of matter. Properties of matter. Juliana, you got it up now?
Yes, I do.
All right,
Wait a minute. Yes, I do.
go ahead.
How could you describe an apple? You might say that an apple is red, brown, and hard. Color, shape, and hardness are three properties of matter. Properties of characteristics used to describe an object. Mass and volume are two basic properties of matter. Weight and density are also basic properties of matter. Weight is a measure of the pull of gravity on an object. Density tells you how much matter is in a certain volume.
Okay, what do you guys have? What's important?
Properties of characteristics.
And Sophia?
A property is a characteristic used to describe a substance.
Characteristics used to what? Characteristics used to what?
Used to describe a substance.
Good. Cal?
Three properties of matter: color, shape, and hardness.
Color, shape, hardness. Here?
Mass, volume, weight, density.
Sure. We could add that. Mass, volume, weight, density. Squire?
Weight is a measure of the pull of gravity on an object.
That's getting into more specifics. You could do that, but since we're using these as examples of properties of matter, that kind of just takes care of it right there. We could get into define each one of these. Color would be the light that it reflects on the electromagnetic spectrum, and shape would be its outline. Hardness is how tough it is. We could get in and make a real long set of notes on that, but since we're just doing examples, that's pretty much the way to go. There needs to be a space between mass and volume. So, properties are things, these especially are things that we can see. These are physical properties. When we get into section 3, we'll talk about the difference between physical and chemical properties. If we look at this hole punch, what are the properties? Somebody raise your hand and tell me a property of this hole punch. Madison?
Color,
What's its color?
black.
Good. Black. Name something else. Sophia?
It has silver.
It's got a little bit of silver back here. Yeah. Squire?
Weight.
Weight. It's got some weight to it. Maybe half a pound. Maybe.
Yeah.
Okay. What else does it have? Sophia?
A line
A line glue. It's got a little bit of a gap going more toward its shape. Squire?
I'm not sure if this is true, but like it's mass.
It's mass. It does have mass. Yeah. Madison, what about you? What's the physical property of this? Its shape. What kind of shape is it? She's got it. How about that? Now what shape is it? Kind of a rectangular shape. Okay. Lily, what about you? What else is something you can use to describe this? What property? Anything. What describes this? It's black. Okay, we got the color down. Is it long? What about its length? About how long do you think it is? Take a guess.
I don't know.
Take a guess.
I don't know. How long? I don't know
About how
what
long?
it is.
5 times 2.
10.
10. About 10 inches long. Give or take. 10 to 12 inches long. Alright? But those are properties. Those are characteristics that we can use to describe any substance. We can do it for any substance. We can do it for a chair. We can do it for water. We can do it for anything. But it's properties that we use to describe a particular substance. Okay? Let's read about the study of matter. Tyler Evie.
The study of matter and the reactions of matter is called chemistry. Scientists who study matter are called chemists.
Good.
Chemists study what different substances are made of. They do experiments to learn how different kinds of matter can change and combine.
Good. Alright, what note do we have? Who's got a note? Jared?
Scientists who study matter are called chemists.
Good. So we can do chemists. There are scientists who study matter. Callum?
We learn how different kinds of matter can change and combine.
Who do?
Chemists.
Chemists. Okay, so we can do a subnote on them and say what?
They learn how different kinds of matter can change and combine.
Good. Sophia?
Chemistry is the study of matter and its reactions.
Good. And then chemistry is what?
Is the study of matter and its reactions.
Good. Anything else? So chemistry takes different substances, different elements, like that element project we just got done with, puts them together and kind of sees what happens. Now, this was kind of in the video we watched last week, but there are only about, I think there are 112 elements now, but 110 to 112 known elements on the periodic table. Okay? Those 109 to 112 elements all combine together to give us everything that we have and know about in the universe. Pretty crazy, right? All right, let's turn the page and let's talk about phases of matter. Okay? Phases of matter is just a nice complicated way of saying solid, liquids, and gases. Nice complicated way of saying that. But we're going to talk about what make those things solid, what makes them liquid, and what makes them gases. Okay? So let's start reading about phases of matter. Madison McWhorter.
You cool drinks with ice cubes. You wash your hands in liquid water. You iron the wrinkles out of your clothes with steam. Ice, liquid water, and steam are all made up of particles of water. Different forms of the same substance are called phases. A phase is a form of matter. There are 3 main phases of matter. They are solids, liquids, and gases.
Good. Who's got a note? Olivia? We're gonna get out of the middle rows.
A phase is a form of matter.
Okay, so a phase is a form of matter. Olivia, or sorry, Juliana.
Solids, liquids, and gases are
Okay.
the three main phases of
Good.
matter.
Three main phases: solids, liquids, and gases. Good. Connor, you got something to add?
I just have it in like more fun path. I have the same stuff though.
You just have it in the form of matter, the three main phases, all in one note.
Mhm.
That's okay. That's okay. Okay, so matter takes place. So we have matter all around us. We know anything that takes up space is matter. And we determine that the phases of matter are in these three phases. So matter always shows up as three types. It's either a solid, a liquid, or a gas. Right? Solid, a liquid, or a gas. All right, let's read about solids. Let's read about solids. Lily, read about solids.
My book is not
Your book isn't loading?
Most of the objects that surrounded you are made of solids. A solid is a phase of matter that has a definite shape and volume. In a solid, particles of matter are tightly packed together. Particles cannot change position easily. They can only vibrate or bend back and forth in loops.
Good. All right, so what do we have for solids? What do we have for solids? Tyler Evie, what do we have for solids?
Most of the objects that surround you are solids.
Okay, most of the objects around you, we could say that, so most objects are solids. Master Danny, what do you have? Remember what you had? Okay. Juliana?
Phase of matter with a definite volume but no definite shape.
So it is a
Oh
phase.
wait, are we looking at solid?
We're looking at solids, so phase of matter with what?
With a definite shape and volume.
With a definite shape and volume.
I was looking at liquid, my bad.
That's all right. Very good. So solids have a definite shape. Their shape doesn't change. Okay? If we look at this beaker, okay, we can see that it is its own shape, right? We can take it and we can measure it to know that it has its own volume, but it always is going to keep this shape, right? Even if I break it, it's still going to be a solid, correct? Okay, that's something to remember. Solids are going to maintain their shape, and we're gonna be able to figure out their volume. Yeah.
But like, does that contain like a like when water goes in ice?
So think about this: with ice, when you freeze ice,
Goes
it's a solid, right? And it holds that shape until what happens?
melts.
It melts.
So then it goes to
Then it goes to a liquid, which we'll get to liquids right after this. Okay? So, big thing to remember is the way we're going to define these solids, liquids, and gases. You know that this is solid because you can look at it. Okay? But what we're going to have to make sure that we remember is that it is solid because it has a definite shape and it has a definite volume. We can know those two things and know that it's solid. All right? Let's read about liquids. Squire, go ahead.
Milk is a liquid. A liquid has a definite volume, but no definite shape. Liquids are able to change shape because particles of a liquid can change position. They can slide past one another if you pour a liter of milk into different containers. The milk always takes the shape of the container. However, the volume of the milk stays the same because you cannot make a liter of milk fit into a half-liter bottle.
Good. Okay?
Excuse me, Mr. Buckley?
Yes, ma'am.
Hi, I need Lily Davis for dismissal. Downstairs office, please.
She's on her way.
Thank you.
Have a wonderful day. All right. Just work on those checks. If you have problems, make sure you email me, okay? All right. So, what do we got for liquids? Who's got a note? Sophia.
It's a phase of matter with a definite volume
The particles can slide past one another.
Good. Particles. Okay, Jared?
Change shape because the particles of a liquid can change position.
Slide past one another. We'll add to this note for that. So particles can slide past one another, giving it different shapes. Okay? Alright, so we can see that the liquid in this beaker has a definite volume, right? We can see the little measurement. It's got 100 milliliters. Okay? Does it have a shape?
Yes.
Yeah, it's container shaped, like a cylinder, right? So if I take this beaker and I pour it into this one,
It's just making the shape.
have I changed the volume?
No.
Have I changed the shape?
Yes.
Yes. Water and other liquids will take the shape of whatever form they're in. If I had this in a regular water bottle over here, it obviously takes the shape of the water bottle. Okay? Juliana's got a water bottle over here too. Notice, her water, again, takes the shape of the container that it's in. Okay? So the shape can change. If I took this water and poured it out on the floor, what shape would it contain?
The floor.
Yeah, it would try and spread out to the floor, right?
But then it would dry up and evaporate.
Right, we're not to evaporation yet. Okay? Alright, let's read the last one. Let's talk about gases.
I have a question.
I have an answer. Yes, sir.
Why is it that and when like all liquids on the ground, it evaporates a lot quicker because it's spread out more?
Surface area.
Okay.
And we'll talk about it. We're going to get to evaporation. We'll talk about it then. Alright, let's talk about gases. Let's read the last section on gases. Madison Denny.
A gas is a phase of matter that is now definite shape or volume. Here is a gas. Here has different shapes in a basketball, football, and a bicycle tire. If you fill a balloon with air, the air completely fills the balloon. A container of gas is always completely full. The particles of gas are in constant motion. They are much familiar or farther apart than the particles in solids or liquid. They can move freely to all parts of the container.
Good. Alright. Who's got a note? Julian.
Phase of matter that has no definite shape or volume.
Good. Phase of matter with no definite shape or volume. Connor?
Particles of a gas are in constant motion.
Good. Particles. Okay. Sophia?
They are much farther apart than the particles in a solid or liquid.
So we'll just add to this no particles of a gas are in constant motion and far apart. All right. Anything else? All right. So, going back to our beaker examples. Is there air in this beaker?
Yes.
Yes.
What's the shape?
A
Cylinder.
Cylinder. Okay? A cylinder. What's the volume of it?
Circular.
A little bit more than 200 milliliters.
A little bit more than 200 milliliters, okay? Because we capped it off, 200 milliliters is there. It's a 250 milliliter total, but since I got it all up. So, this beaker, we know has air in it, okay? But the shape of the air always conforms to its space. Now, what is the shape of the air particles in this room?
Rectangle square.
Free.
Rectangle square. They're free. They're moving all around. Okay? We sit here and go like this. Air particles are all around. We can feel moving around, right? You want me to stand up and flap?
Yeah.
Please, no. I can't do like
Can we all stand up?
Sure, let's all stand up and flap. Everybody up.
I
Let's go.
can't
Up, up, up. Okay? Because this is how we can tell that the volume and the and the shape of all the particles are different, because every time we move, oh come on, everybody up.
I can do
Up.
I can do
You
it
can
from
stand
my
up too.
chair.
Up, up. Juliana, you can just stand on one leg. Come on, you'll be alright. Up. Madison's up. Up.
Oh my god, this hurts.
It still hurts.
No, Miss Buckland, standing.
Alright, so as you move around, as you move your arms, you feel yourself moving those air particles around, right?
Yeah.
No.
Olivia, this. You can feel air particles moving like this? Come on.
Yes, I can.
You got to
Alright, you can feel the air particles move. Are we constantly changing the shape of the air around this room?
Yes.
Yes, every time you move, the air in the room is changing its shape. Alright, back to your seat.
Is there a way of like, just like magnetism, is there a way of seeing your,
Seeing air.
yeah, like the moving?
You can see air when you put baby powder.
Yeah, little things like if you have like steam or fog, sit. Don't ruin the fun. Sit. Good choice. Okay. So, do we have any other notes that we need to take?
No.
Do we see the differences between solids, liquids, and gases? All right, let's compare our notes to the notes that we have on the other side.
Mr. Beckley,
Yes, sir.
is there a possible chance of like making liquids not move at all?
Yes, it's called freezing them and turning them into a solid.
Really? That's it?
That's it.
It's the only way?
Is Jello considered a liquid?
Jello has a definite shape, so we'd call it probably a solid. All right. So
How is it a solid when it still moves? Because it's Jello and
Can't solve.
wiggle.
It's both.
you can move it.
It's
Jello's the exception that proves the rule. All right. Let's look through the phases of matter. First one, anything that has mass and takes up space. We had an extra one saying the amount of matter an object contains. Good. Properties of matter, characteristics used to describe a substance. We had examples. The last one, studying matter. Chemist is what they have. We had chemist and chemistry, which I like the idea that we had chemistry, especially because that's one of your tech terms. Okay? Sophia, that's bad for your computer and you. Put it down like mom.
Why?
There you go. Alright, let's check the last one. Anything we needed to add?
No.
Alright. Last one, phases of matter. We have the form of matter, and the three main phases are solids, liquids, and gases. Good. They flip-flop these. So liquids is a phase of matter with a definite shape, or with a definite volume, but no definite shape. We have that. Solids, a phase of matter with a definite shape and volume. And gas, a phase of matter that has no definite shape and no definite volume.
Remember in 7th grade, Alex Rashner used to always figure out a way to like remember the
He did used to come up with acronyms.
so funny.
Alright, let's look at one more thing, and then I'm going to turn you loose on your homework. Okay? So this is just showing you the way particles act in solids, liquids, and gases. So, here, in a solid, the particles are tight, they're compact together, and they're just sitting there kind of vibrating. They're not really moving that much. Okay? When we're talking about water, if we're talking about water, what phase of matter in water is a solid? What do we call the solid phase of water? Ice. Ice. Okay? In a liquid, the particles are able to slide back and forth, they're able to move around, but they're not free-flowing. Notice we have a definite volume, but the shape is the shape of the container. What do we call liquid water? Water. Simple. Water. Okay? In a gas, the particles are free flowing. They're bouncing all around, and their only limit is their container. The air in this room is limited only by the walls of this room.
What if you open the door?
You open up the door, then they compare out here. So if we open the door, now we've increased the shape of the room. So there's more air, but it's also moving in and out. Constant moving, constant motion.
Actually, it goes in the vents.
It does go in the vent as well. That's air
Put
circulation.
it out under the crack.
It'll still do that, for sure. Okay? What do we call gaseous water? What do we call water in
Steam.
gas form? What'd you say?
Steam.
Steam.
Steamy.
Steam. All right? Any questions on solids, liquids, or gases?
But I do have another question.
Is it about solids, liquids, gases, or phases of matter?
Not really.
Then let's wait till after class.
Okay.
All right? All right. You guys have about 10 minutes before I sign you off so you guys can get to work on your homework. No.
Are we not allowed to do our homework?
You're allowed to do your homework. Take advantage of this time I have given you.
What if
Not gonna get older, in the room.
Then you can use a book.
No.
You can see if Madison's charger works on your computer. Is your computer dead?
Not really dead, but it's
You can use that. You can write it down and then transfer it over. Madison's so sweet.
Madison. You can have the book back, Mr. Buckles.
Thank you. Is your laptop dead?
Yeah.
Okay.
No.
You can start taking your notes, answering the questions. Then all you gotta do is just copy them over there. Jared, pick it up and put it in the trash can. Thank you.
Who's Maddie
Go get
Moore?
work.
She says hey.
Get to work.
Is the check just be on the right side?
No, Chess is on the left, worksheet's on the right.
Good job, double check. Remember if everybody looks at section 2 real quick. Remember you're doing the apply just number 7. If everybody looks at that, B, seltzer.
Is it water?
Would you like to tell you that? Okay. A seltzer is just it's a tablet. It's like a pill. You used to put it in water, it dissolves in water, but it is in and of itself it is a solid. Okay? It's a solid. Seltzer would be the only one you guys probably wouldn't know. All the rest of them you should be fine.
So we just write A, B, C, D, E, and you say what's a solid, liquid, or gas?
Mm-hmm. Yep. She gets back. And Tyler. How about you, Eval? Can you take your notes?
Number 6 was interesting.
Look at the last sentence of properties.
So the water that you drink is taking the shape of your stomach?
Mhm.
That's kind of weird.
But remember, think back to 7th grade science. You already have liquid down there, so it's just adding to it. Because the liquid's already in your stomach is that acid.
But, but your acid's eating the,
No, it's breaking it down, it's reacting with it.
is that sometimes like how you get stomach aches or something? Because your acid or whatever is not doing its job?
Or it's doing its job too well. It depends. Depends. If you're having a stomach ache because you have a bug or a virus, that's just your body reacting to it. If you're having a stomach ache, say because you haven't eaten anything, that's just because your stomach acid is looking for something to eat.
Mm-hmm.
Make sure you guys take your notes on section 3 as well. You have 1, 2, and 3 to do tonight.
That's what we did last.
For 1 and 2. We'll bring it to your notes for section 3.
Wait, what's up there again?
Seltzer's like a tablet, antacid tablet. In about 2 minutes,
Wait, no, 2 minutes.
until I come and sign you off. Done all of it? Alright, how about you, Trevor, so I can sign you off? Sign you off and you sit tight until I'm gone.
Can I go to the restroom quickly?